Let's go ahead and review the sum and difference of cubes to see how their formulas work. For starters, we're going to use the example x cubed plus 216 y cubed. You'll always see it in this form where we have two terms, and it either has a plus or a minus. To make sure we can use this formula, we need to identify the perfect cubes here. We know the cubic root of x cubed is just x, and I can put the cube here, plus the cubic root of 216 is 6. And you may not know that off the top of your head, but you can work it out. And then we have y, all in parentheses, cubed. So what we did was we identified what the cubic root of each of these terms equals. So x cubed, that's x, 216y cubed, that's 6y. With this form, we can go ahead and plug in the values just following along with the formula. So I'm going to identify them by color after I lay it out. This equals, using the sum formula, in parentheses first, x plus 6y, times, now you take the x quantity and square it, minus the x quantity, times the y quantity. What's the y quantity? It's 6y. So I'm going to go ahead and highlight that. 6y, 6y, this needs to be 6y. So let's put that down. We have 6, oh, not the highlighter, we want the pen. 6y, okay, plus the y quantity, which was the green underline, 6y quantity squared, close parentheses. Okay, so let's make sure we have everything highlighted correctly. We have our 6y quantities here. We have our x quantities here. All right, so kind of see where all the pieces fall. Notice how I'm writing it though. Since I identified the x and the 6y, I can write everything in terms of x, 6y. X, right, that's quantity squared. X, 6y, 6y, quantity squared. Okay, so all the pieces fall into this nice little structure. And then from here, what we want to do is simplify. So we're going to leave behind all the noise and just reduce. This is x squared minus 6xy plus 36y squared. And the last step for an example like this is to check, can I simplify this further, or can I factor this further, right? This is a trinomial. This would be difference of, well, that wouldn't be a difference of. That would either be a quadratic formula to solve, or that would be the factoring using factor techniques, right? So we can do a quick test on our product sum. The product is 1 and 36, so what multiplies to 36 and what adds up to -6. I don't think we have anything here, and we could list that out to check. We have 1 and 36, 2 and 18, 3 and 12, 4 and 9, not 5, but 6 and 6, and then we repeat in the other direction, right? We can make one of those terms negative, the other positive, and you see just to combine them, this is reduces to 35, 16, 9, 5, 0. None of those would be a -6. Okay, so that tells us that we need to use the quadratic formula if we had to factor this further. It's going to give us a radical or an imaginary solution. So that's as far as we want to take it, but you should always check just to see, can I factor this further into something nice like, say, x plus 6 times x plus 6, right? Can we factor it into something nice like this? In this case, we can't. I don't want to lose sight of that. We don't need to worry about that. So where we stop is right here. Next up, we're going to look at this same example, but I'm going to swap this from a plus to a minus, and then you'll see how the signs fall in differently, but the structure remains almost exactly the same. So next up, it's x cubed minus 216y cubed. The only difference between the previous example and this example is our plus became a minus, so we need to use the number 2 equation here, the difference of perfect cubes. As I said before, we want to identify that this is x cubed minus the quantity of 6y cubed. So let's go ahead and lay into the formula. What do we have here? We have x minus 6y, the quantity inside the parentheses, times the x quantity squared minus the x quantity times the y quantity, right? 6y plus the y quantity squared. And you may have noticed I missed something already, but this is where I want to double check against my formula. X minus 6y, x squared plus, this is the change, this needs to be plus x times 6y plus 6y cubed. So once you write it out, double check yourself against the formulas, okay? If you need to memorize this for class, take the time to write out a couple examples a few times each, and then test yourself daily. Doesn't take a lot of time, right? I'm talking 1 minute, 2 minutes at most. Don't just stare at it, actually write them out. Okay, take a few examples, even if it's just a cubed minus b cubed, and write it out. What should that equal? Okay, that's what's going to get you comfortable with plugging into this formula. So let's go ahead and simplify what we have. X minus 6y times x squared plus 6xy plus, and this is where along the way always check what you're writing, because you'll notice, like I did, we make certain little mistakes every now and again, and that's okay. Let me get my eraser up, if it will actually erase. There we go. That should have been a square. Square. X minus 6y, double check my work, x squared plus 6xy plus 36y squared. Okay, same as before, double check yourself here, right? Is this an easily factorable trinomial? Can I write this out in a form that works? Well, instead of subtracting, I'd be combining my terms. And if you recall, it was 1 and 36, well, that's 37. 2 and 18, that's 20. 3 and 12, that's 15. 4 and 9, that's 13. 6 and 6, well, that's 12. So none of them would add up to give me the middle term 6. This, again, would be a quadratic formula to solve. We don't want to go down that path because it either leads to a radical or an imaginary solution. So we want to keep it a nice whole value. So I'm going to rewrite this so it's clean. X minus 6y times x squared plus 6xy plus 36y squared. All right, that's our end result. That's as far as we need to go to consider this in fully factored form. Let me know if you have any questions, right, or any other examples you'd like me to go through. Sometimes you'll see an a value in front of this. Right, instead of having ax cubed, you might see something like, what's a perfect cube? It's 27, right? Same as before. All we need to do, if this was a 27, is inside here you just use 3, because 27, take the cubic root of that, you get 3. And then you fill in 3 along with all your x's, right? Everywhere you see this x quantity, this x quantity, this x quantity, we're going to go ahead and plug in whatever's right here. All right, good luck.